So we'll just revise once before I jump into code. So uh, it's the first step is our significant level that we have to decide. So which we decide for now, let's say 0.05. Then fit your model with all the predictors that those you have in your model, irrespective of thinking of any coefficient or dependencies, etc. So once you do that, then consider the predictor with highest p-value. So once you fit the model, build and fit the model, just check for the p-value of all the variables. I will show in the code how to check that. We don't have to calculate the p-value manually. Okay, so there is some underlying formula, mathematical statistical formula underneath, but we don't need to bother for that. The model calculates that for us. We just have to look at it and take our decision based on that. I will show you in that code. So consider the predictor with highest p-value. So as we said yesterday, the it's inverse relation actually. Higher the p-value, more insignificant the predictor is for our result. So we have considered the significance level as 0.05, 0.05. So we'll see whichever p-value is greater than our significant level. So we'll just drop that. Step 4 is drop that predictor. So note that, I mean, when you build it a first time, there may be chance that there can be multiple predictors having more than beyond our threshold value. But we have to just remove one by one. We don't remove all of those who have crossed the limit. So at a time, only one we have to remove, which is the highest one. And then step 5 is again fit the model with this variable. So remove that predictor and again fit the model, build the model, and again repeat the steps. So we have to repeat these 3 4 5 until we get whatever predictors having their values, or their p value within our significant level. So we'll go into code now. So this is our 50 startup data set. 50 startups, their administration, marketing, etc., all the spendings, etc. And here goes the code. So what I will do is I will just reset my kernel so that we can start all over again. So first and foremost, we have to import the libraries. So the NumPy, Matplotlib, and Pandas, these are the three standard libraries we import every time. So we'll just go ahead and import them. So here is our console. So that's good, that goes successful. I mean, just before that, you have to ensure that the current directory is set right. So wherever your CSV file is, data file is, you just have to open that directory and set your console. Click on this tab here, set console working directory. So that directory will get set as current working directory. So that's just small prerequisite. So now we have imported these libraries, three libraries. uh, then the 50 startup dataset. So we'll import that. Just import that, control enter. So that imports it. This is the variable explorer. We can see what variables we have in our environment now. So dataset, we have given name as dataset. So we have dataset and it has a data frame. So this is what it is. So whatever you see in the Excel file or CSV file, the same thing you see in here as well. So index start with 0, goes all the way up to 49. We have 50 rows in this data set. Okay, then as usual we have to split the data set into two. One will be uh, independent variable, one set will be independent variable which will be x essentially, and y will be our vector of dependent variable, which is essentially is result. Okay, so what we have done here is essentially this colon means all rows. First parameter is rows here in this square bracket. Then again colon means all columns, and then minus 1, so all columns but 1. So it will take R&D spend, administration, marketing spend, and profit. So profit is the last column, and we have done minus 1 here, so it will just leave profit aside and will take all these other four. Okay, so yeah, so it will take for this semicolon, first semicolon, it will take all the rows. So before comma, it's all the rows or whatever rows you want to mention. So colon is like star or wildcard kind of thing. So it will take all the rows, and then after comma, it's the columns those you want to take. So again, we are giving colon minus 1. So all the columns, but leave the last column there, excluding the last column. So it will take up to state. We will see just here right away. So if you just execute for x, so we have got x here, but we will not see x here by double clicking because it's a object type. Why it is object? Because we have different data types in one vector there. We have numbers and we have string as well. So the state column that is having string there, so that is why it is object. So we will not be able to see that here, but still we can see that on the console itself. So if we just type the variable and enter, it will show you uh, all the values in it. Okay, so if you note, it has taken all the first three columns which are having some values: administration, R&D, etc., and the New York or California, the state column, and profit column has been left behind. So profit column will take in the y variable here. So it's again the same thing, but it's just one column we want there. So colon means all the rows, comma 4, so only fourth column it will take in that case, because profit is index 4, and in index in Python starts from 0. Profit, yeah. So if we go to data set 0 1 2 3 4, 0 1 2 3 4. So we'll execute for y also. So now y is also there in your our environment. So this is float, so we can double click and see that. So this is our y. So these are the profit numbers for all the 50 rows. Okay. So now we have got our x and y, independent and dependent variable, in a separate vectors. So now comes the categorical data. Yeah, so if you remember from yesterday, I'll just go to that slide quickly. Yeah, this one. So we have a categorical variable which is state in our data set, and we are going to convert that into our dummy variables. We have three categories, so we have to get into three, right? So we'll see how we can do that here. So we need a pre library here, or the objects here, label encoder and one hot encoder. So these are the two classes or objects in this Python library. So label encoder is the one which help us do that, and one hot encoder does the uh, final fitment of the columns. So let's just import the libraries first. So okay, imported. Create a label encoder object. Create a label encoder object. Label encoder X. Okay. And what do we need to transform, right? So in here it is the third column in our data set which we want to transform. Okay, the state column, the New York, California, Florida, etc. So that is the index of that column is 3 in our data set, or the X variable now. 0, 1, 2, 3. So yeah, so 3 is the column. So label encoder dot x, the object label encoder object that we created. So we just have to call a fit transform method on that, and pass on our object of interest, which is x in this case, but we have to give a specific column for which we have to do this encoding. Okay, so for ours is it's a state column, so which is 0, 1, 2, 3. So 3 is the index, so we have to pass a specific array or index to that, so that's 3 here. Okay, so we'll just execute that again. Okay, then it's the one hot encoder. So it's the one hot encoder which does the uh, categorical encoding for our column, which is the state column here. So if we just execute these two lines, so this line is just a object of one hot encoder, uh, and this is where we are actually doing the transformation. So it has gone through, it is showing some warnings, but that is okay. That is because of some library mismatch and some deprecation uh, messages there, which is okay, but our code has gone successfully. So if you notice here on our variable explorer now, so X has got transformed. The type has been converted to float 64. Earlier it was object, right? So it's float 64 because now that state column also has got transformed into numbers. So let's have a look at it, what it is. So this is how your X object is now. So these are the three columns pertaining to the state, and these are the other three which are administration cost, R&D cost, etc. So if you notice this 1 0 0 0 1 0 0 0 1, so at a time only one will be there. Yeah. Hmm. Hmm. That has been done by this one hot encoder. Okay, because we if you see here, if we have passed the number or index of the column for which this encoding has to be done. In this case it was 3. Okay, so we told this encoder that it is the third column, or index number 3, not third actually. Column is 4, but index number is 3, for which we want to do this encoding. So we passed that number 3 here. You have to pass that index of that column for which you want to do this encoding. So that is why it has done that for the state column. So it identify by itself how many distinct values in that column, and then accordingly it puts those many new columns in there, and assign one for one column and zeros for other column. So that is what it does. It has done that for our state column now. Okay. Okay, so we got X, and if you remember, I spoke about the dummy variable trap, avoiding dummy variable trap here, right? So whatever dummy variables you have, whatever columns you have, you just to have -1 columns for that dummy variable. So in this case, we have three categories: New York, California, Florida. So in this case, we'll go with 3 minus 1. So we just want two of those columns. Any of the two column will solve our purpose here. This is to avoid dummy variable trap. So it's not a big deal. It's just we have to drop one column from our X data set there. Okay, so all that we have done is we have assigned X to X, but we just have taken all the rows and left one column from here. So let's see what it does for us. Okay, no. So if you see here, we have just what we have done here is what this one colon means. Remember, here we had colon and then -1. So all the columns and leave one column from last. That is what sequencing it is what matters here. Okay, and here we have done one and colon. So all the columns but start from index 1. Okay, so start from index 1, and then from there onwards, whatever columns are there, you take all the columns. It's that way. Hmm. So I have executed this. So if we again see X variable, so now we have this as a X. So if you see, only we only have two columns here now, 0 and 1. There is no third column which is having again, so some one of the state has been dropped off to avoid dummy. Look at this, these 44 number 00, right? So this row doesn't belong to maybe California and Florida, so implicitly the model understands that this row belong to Florida or New York. Actually, first column was New York, so that way it implicitly takes the same case for this 47 also. Okay, so with this we are avoiding the dummy variable trap. Then this is again just a normal case of splitting the data into training and test set. So you just have to import this library. Uh, okay, successfully imported, and then you have xtrain, xtest, ytrain, ytest, and very standard way of doing is just that we have to mention the uh, distribution, percentage of distribution. It is zero point 0.2 here. We'll keep it as zero point 0.2 for now, which is okay. Just execute this. Yeah, so it has gone through successfully. And if you just notice here, we have those variables here: xtest, xtrain, ytest, ytrain. Okay, then comes our main part. Okay, so up till now it was more or less was pre-processing and cleansing the data if needed, and then dummy variable and things like that. Now is the actual linear regression that we are going to do here. So that way it is pretty straightforward, simple. So we have a linear model as a library here from sklearn. So sklearn is our collection of libraries. Scikit-learn is the full name, and we just want a linear regression object from this library. So we just import that. Okay, then create a regressor, just a plain object with a empty parenthesis. So we got this regressor here on which we are, this actually is our machine, and on that we have a fit method from this linear regression class, to which we have to pass two parameters, so xtrain and ytrain. So our, this is our training set. So x is our independent variables, set of independent variables, and y is our dependent variable. So if you notice here, we have splitted our main data set into two, into 80-20 ratio. So xtrain must be having some 40 rows, and ytrain will have again 40 rows for uh, same set of rows there. So we'll just go ahead and execute this regressor as well. Okay, so it has gone successful, and when it is successful, you will see this message here out, whatever 15 is the row number here, and then the linear regression, and then whatnot parameters it has used as a default parameters is showing that. So we have this regressor object gone through. So regressor is now trained with the xtrain and ytrain training set. So we have our regressor or our machine ready. Okay, and then is the point where we have to predict the result. Okay, so now we have trained our model with a training set, and next thing is we have our test model, wherein we have x test and x test and y test. So x test is again in uh, independent variables, and y is corresponding dependent variable, the profit essentially in this case. So we just give a variable name pred is predictor, so just to have it distinguished, identifiable, because our test sets variable is y test. So we pass x test as a parameter to the regressor's predict method, and it will predict the profits for all those 10 rows, and will give us a ypred, vector of ypred. Okay, and we can then compare it actually, at least in this case we can compare manually, and we'll do it now. Okay, so it has gone through. So we have now ypred in our kitty. So this is your ypred. Okay, and let me pull the y test. This is our y test. Okay, so the head to head comparison. Okay, so y test is our actual number. Okay, the actual physical result, which is 100% right, because that is what is given. And ypred is the variable which we, our model regressor, has predicted. Okay, so for a very first thing, it is actual result is 103,282, and our regressor has predicted 103,015. Pretty close, pretty close. Okay, so second row is 144 to 59, and here it is 132 580. Not that close, but still okay, not way too off. Third one, the index 2 146k. Here is 132k again. So comparable results, not very off and not exact 100% or 99% as such, but the results are pretty comparable if we just put them side by side. Okay, so this is what we have tried to do without any what you can say, uh, enhancing the model for betterment. So which is what we are going to do now as a next step, which essentially is backward elimination. If you remember, I will just go to the slide once again for backward elimination. So this is the backward elimination. We just recapped on this in the beginning of the lecture. So we will fall through all these steps here now programmatically, so that will give a better understanding. So again, some standard library we have to import. So it's the stats model formula API, and SM is the library there for that. Let's import that. Okay, and we have here x is equal to np append arr np once 51 as type integer, then value x, axis is equal to 1. So what essentially we are doing here, okay, I will explain you by going back to the slide again. If we go back up here, or rather here, so this is our regression, linear regression formula, okay, with multiple independent variables in there. So if you notice, we have y is equal to b0 plus b1 into x1 plus b2 into x2, and so on. So if you notice this very first variable, which is just b0, it doesn't have x0 or something, right? So it's just one simple constant up there. So what this is, so this is essentially, we still have x0 here, but it is given that x0 will always be having value 1. X0 will always be equal to 1. So whatever is the value of b0, it will remain the same. Yeah. So this is what we are doing here in this step. Okay. So what we are doing is, we are just adding that x0 to each of our data set, each of our line into data set rather. Okay, so we'll just quickly explain in this API. So NP is our NumPy library which help us play with numbers, etc. in Python. Once is one kind of API in that library again. 50 is our number of rows in that data set. We have 50 rows in our data set, and what we need to append is 1. So that is that one here. If you have to add 2, you can write 2 here, it will add 2. Okay, and then as type. So what it should add 1 as. So we are just telling the model that it should add or append 1 as integer. Otherwise it might add as a float or double or something. So we just want to add that as integer, nothing else. So that is that. And then values into x. So all the values, all the vector that it has to consider as x here. And axis is 1. So this is a very standard thing, we can take as is right now, nothing much to discuss or talk about this. So it will always be axis is equal to 1 whenever you are doing with any of your vectors in practice. So we haven't executed this line, so we'll just have a look at our x once again. Okay, so we have 0 1 0 0 1 0 0 1, and then the other variables, three variables we have. Okay, now we'll just execute this line. Okay, gone through. Now if we look at this, see, it has added all the ones here, all the 50 rows. It has added one as a first column. So this is what we have added x0 to our data set. Okay, so going back to our slides for these steps for backward elimination. So significant level, okay, we have decided in our mind that it is 0.05. Then fit model with all possible predictors. So this is what we are doing here in the very first line here. Okay, so 0 1 2 3 4 5, we have 5 variables in our x now. 0 1 2 3 4 5. Okay, so we have taken all the predictors, and so we have just given a new variable name there because we just don't want to override x, because we have to tweak this x opt all over again down the line. So just taken a new variable, and then given that x opt, which is our which is having in the very first step, x opt and x are the same actually. Okay, because it is having all the columns there. So we pass on this x opt to the model with sm.ols. That's the API for our sm class here. So we pass this, we fit this into our regressor. So we have created a new regressor as well for that. We want to retain the previous regressor just for reference purposes. So we'll just retain that and have created a new variable here. So let me just execute these two lines. X opt. So we have got x opt here. Okay, so this right now it is almost, not almost, it's same as our x variable. Now we will just go with this fitment. Okay, so we've got the regressor OLS now. This has gone through. Now comes the detailing part of it. So as if we go back to slide, so we have built our model with all the predictors 0 to 5 here. Okay, now consider the predictor with highest p-value. So how to see the p-value? So this is your regressor. So on that regressor, you just have to call a method summary. Okay, so we'll just call this method summary or on our regressor. So I will just expand this screen here. Okay, so here you go. So you have lot of information here. So we don't need all of them right now. Maybe we will need it in future iterations or future practices somewhere. But it is giving lot of details up here. Okay, for our data set or model, it's r squared, adjusted r squared. Okay, then this is p value, by the way, p greater than t. You see this column? So this is the p value, and this is the p value for your respective each individual predictors. Yeah, so we have how many? Six as of now. So one, two, three, four, five, six. Yeah, so we have six rows here, each pertaining to one predictor, and it has given p value for each of them. So this is our interest right now. Okay, so among this, as I said, predictor with the highest p value, if the p value is greater than your threshold level or significance level, then we just have to drop that predictor. So we'll see our significance level is 0.05 and the highest is anyway very high, it's 990, this one, right? It's way higher than what we have as a threshold, so it's x2. So 0, 1, 2. So if you go by index, this is 0, this is 1, this is 2. So second index we will have to drop. Okay, column of second index we will have to drop. So among these all columns 0, 1, 2, 3, 4, 5. So we just copy this all over again and just drop 2 from there. So now we have 0, 1, 3, 4, 5. We drop 2 from here, and then again, as said in this step, fit the model with this variable and build it again. So we drop this column, get that into x opt again. So now this x opt will have one column less, obviously. 1, 2, 3, 4, 5. Yeah, instead of 6 we have 5 columns now. And then again build this model. Okay, and then look at summary. Okay, so this is again summary of the new model of our second iteration. Okay, so here we had up to x5, now we have up to x4. Okay, the p value 0.9400064. So which one is the highest? Highest is 940. Okay, which is anyways our beyond our significance level, so we'll have to drop that one also. So which is essentially 1. This is 0 and this is 1 index wise. So we drop that index here. So if you drop 1, it will be 0, 3, 4, 5, 0, 3, 4, 5, and just repeat all over again. So I'll just quickly build these two lines. Okay, so with omitting again second column, we have built our model, regression model, and then let's see what it shows as summary. Okay, so now we only have 4 columns. Earlier we had 5, now we have 4 because we have omitted 1, and these are again the p-values. Still 602, which is higher than our threshold value. So index of that is 0, 1, 2. So index 2 will have to drop. So this is the index 2 where we have dropped. So 0, 3, 5. I'll just execute these two lines. Okay, gone successful. And then just check summary once again. Okay, so we have three variables, three predictors now. Two are zeros, and the third one is marginally higher than our threshold actually. We have chosen 0.05 and this is 0.06. So little higher. So we'll have to drop this one again 0, 1, 2. Okay. So okay. So fifth column we have to drop now. So we'll just quickly build this once again and the summary. Let's see what the summary shows. Okay, so here is our summary. So we have constant and we have x1. So constant is essentially our b0 where the x0 is 1. So that is 100% needed. So we cannot omit that. And x1 is the column, okay, which is again 0, 0, 0. So below our significance level, so we can retain that. So 0 and 3. Okay, so if we go into x 2 3, so this is the column which is our final interest apart from b0. Okay, so essentially that will be, let's look at our data set. X opt, okay, x opt 165 349. It's R&D spend. It's essentially the R&D spend which governs the profit, not even the marketing spend. That is really interesting. So essentially, more you do R&D and keep yourself ahead in the competition by innovating new products and services. That's where the profit lies. That's the uh, extract of the story. Okay, so sorry. Exactly. So essentially, it's the R&D spend. So whichever is company is doing most R&D spend, that is the uh, company of interest for that uh, investor.